Hi everyone, let's go to question number 12. Problem 12. Solve the equation 2x minus 3 equals 9 for x. Okay, so let's just jump into the question. 2x minus 3 equals 9. Right. So we're going to isolate the variable. We got to isolate the variable x in order to solve for this. How do we isolate the variable? We got to get rid of the negative 3 because that's a bothersome number on the left side. So in order to get rid of the negative 3, probably in order to get rid of it, we should add 3 to the left side and the right side. So we add 3 to the left side and the right side. So that is known as which property? Translation property. Very good. Translation property. So we add negative 3 and positive 3, and we have the intended effect, which is turning out to be 0, right? So we get 2x plus 0 equals 12. So we get 2x equals 12. So how do I get rid of 2? Because I really want to find out the value of x. In order to find out the value of x, probably we need to get rid of that 2 by multiplying 1/2. But is that multiplying 1/2 to the left side only or the right side only? We're multiplying 1/2 to the left side and the right side all together in order to use the property known as translation property. That's right. So we multiply 1/2 to 2x, and we multiply 1/2 to 12. So the parentheses, actually the order of parentheses can get changed under associative property. So we can actually switch the grouping property, grouping order, I would say, and that becomes positive 6. So if I multiply 1/2 by 2, let's see what happens, okay? 1/2 and 2, they cancel one another under multiplication, and these are known as multiplicative inverse, right? So we get 1 times x equals positive 6. Now, let's just try to see what happens if you multiply 1 by x. If you multiply 1 by x, we end up getting x. Why? Because 1 identifies whichever number that we multiply with. These are known as multiplicative identity. So it identifies which number that I'm multiplying to 1 to tell the audience that we are multiplying by some x. So here we go. We got x equals positive 6. All right, so right now we found, like an integer solution. So we can't help it. We got to see the remainder. We got to see some remainder properties, some deep fact about mathematical structures. And we're going to divide 9 by 2, okay? If you divide 9 by 2, we get 2 times 4 plus 1. And we're going to divide 2x minus 3 by 2. And that actually leads us to confusion. And we got to think deep about the remainder. If you know about the remainder, if you keep dividing some number by some divisor, the remainder is supposed to be smaller than the divisor, but has to be greater than or equal to 0. So here's what's up. Whichever parts that you get right there has to be smaller than 2, or the divisor, and at the same time, it has to be greater than or equal to 0. Well, it satisfies those properties, so we're good. I mean, we don't have any problem when we divide a number by a number, but we get some variable expressions. We get some letter expressions, so it's going to be confusing. So we have 2x minus 3, and if you divide it out by 2, we get x minus 1. Man, I thought about this expression, and it looks nice to me. I mean, it looks perfectly fine, but what seems to be a problem? That's positive 1. This is negative 1. They're not compatible. They're not the same thing. Okay. So, of course, when we learn modular equations, we're going to say, oh, these are the same things. These are under the same class. But we're not going to use those modular equations. We're literally find a number that actually, are same, the numbers that are same. And we need to find 1, not negative 1. So we're going to think about some other properties. Probably, we can actually write it as x minus 2 plus 1. That's one way of doing it. That's right. That's one way of doing it. And this gets satisfied. That positive 1 that we found, somehow, if the divisor equals 2, then positive 1 is inside those interval. So we're good, right? So what happens to 2 times x minus 3? Well, it would probably be adding up by 3. Well, you know that positive 3 is not going to be the remainder when you divided it out by 2, because that's greater than 2. So we stop at this moment, and we put a box out there, and we equalize these two expressions to notice that we get an integer solution. And that shall be it.